Well, 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 would you look at us? Here we are again. Now it's time for math. Today, it's going to just totally kind of trip you up a little bit. I want you to turn to chapter 11. Yes, that's right, chapter 11 in your math book. I thought it'd be kind of fun to do some new stuff, add on to some old stuff that we've done, and just kind of rest into something that we're kind of familiar with and to have fun with a little bit. So I'd like you to go to chapter 11, solving two-step equations in your book. It's 11-1, lesson starts on page 468. And if you look here, number one, as you remember when we're solving equations, we're going to write the problem. Number two, remember this, we're going to rewrite the problem because we want to always be able to go back and look and see what the original problem was. So in case we've made some little simple mistake, we can find it. And remember, the energy you put into this is going to be equivalent to the understanding and learning you take out of it. Put the hard work in at the front, okay? So that later it's going to be easier. I guarantee when you get into high school and you're doing much more challenging problems where you're solving for variables, if you have this foundation very strong, you are going to have less difficulty. So put your effort in right now, okay? Number three, work from the top to the bottom. Number four, show your steps. 5, show your work. 6, isolate the variable. You want to get that x, y, or z, or n, or m, or whatever it is all by itself. And then you're going to use inverse operations. If you remember that addition undoes subtraction, subtraction undoes addition, multiplication undoes division, division undoes multiplication. Remember those inverse operations so that you can look and see what operation is being performed on the variable and then undo it. And whatever you do to the left side, you got to do it to the right side. Number 7, use inverse operations. Number 8, check your answer by substituting. Once you find a variable, an amount for a variable, you can take that answer and go back to your original problem and substitute in the new value, and it should work out. Circle your answer. And number 10, most importantly, remind yourself that you are a hard worker and you're able to learn new things. Watch what you're saying to yourself in your brain. This is too hard. I don't get it. Nope, scratch those from your vocabulary. With a little more work, I'm going to get this. I'm going to get more comfortable with every single problem I do. It's not a big deal if I make a mistake. I'm going to learn what I did wrong and try a different approach. I'm going to get this. Seriously, you've got to know that you are in charge of your learning and what you get out of it. And you're always going to face difficult tasks in your life. And so you want to have that mindset that's ready to handle it. And number 11, I love you. Always remember that. All right, now I'm going to get my eraser here and clean off this. And we are going to start off with a little sample warm-up. So let's call this warm-up 1, okay? And the problem is n plus 9 equals 17. So the first step, I'm going to rewrite it. And you're not here to help me remember because sometimes I forget my own directions. And I'm going to first say, where's the variable? Okay, n is my variable. What operation's being performed on n? Plus 9. I need to undo that. How do I undo it? Use the inverse operation. It's adding 9, so I'm going to subtract 9. And remember, the center of your equation is right here with the equal sign. If I subtract 9 from the left side, I better do it on the right side. So I'm going to subtract 9 here. And then I'm going to bring down what I have left. N equals 17 minus 9 is 8. Now I can go back up and plug this in. 8 for n plus 9 does equal 17. So we're correct. Do you remember this? I bet you do. Now let's go to warm up number 2. This one is 6x equals 42. The first thing I'm going to do is I'm going to rewrite my problem. 6x equals 42. What's my variable? Oh, my variable is x. Okay, I want to undo that operation. 6 is being multiplied to x. What's the inverse operation of multiplication? Division. So if x is being multiplied by 6, I'm going to divide by 6. If I divide the left, I've got to divide the right. So I'm going to divide the right by 6. 6 divided by 6 makes 1. 1 times x is x. 42 divided by 6 is 7. X equals 7. Now I can go back and I can plug it in. Let's see if it works. Is it true that 6 times 7 is 42? Yep. 42 equals 42. No problems. Let's go to warm-up number 3. Warm-up number 3 is 71 minus z equals 55. Okay? Now, a couple things you might notice here. What's our variable? It's the letter z, but notice what's in front of the z. It's got that negative sign. Okay, so like I said, we're going to start by rewriting the problem so that we can never mess with our first one that we have up there. 71 minus z equals 55. I don't really want to deal with a negative z, okay? But I'm not going to worry about that at first. I just want to get that by itself. I'm going to show you 2 ways to work this one. But I want to get rid of the 71. This 71 is a positive 71. How do I know that? There's not a negative out here in front. Okay, it's positive. So I'm going to subtract 71. If I subtract 71 from the left side of the equation, I have to subtract 71 from the right side of the equation. So now I have negative z equals 55 minus 71. I'm going to take out my handy dandy calculator and I'm going to subtract. I'm going to find the difference between 71 and 55, which is 16. And I notice that I've got 55 minus 71, which is negative 16. We've got 55 positives and we have 71 negatives. When we subtract and we find the difference between 55 and 71, our answer is 16. And then we say, what number appears to be the largest? It's the 71, so we've got to take that sign in front, which is a negative, and we're going to put it in front. And hopefully some of this verbiage you're hearing is reminding you of things we've gone over in the past, but it's okay, you're going to get it. So our answer is negative z equals negative 16. Now to get rid of the negative sign, I can simply multiply both sides of my equation by a negative 1. Negative 1 times negative z, 1 times z is z, negative times a negative makes it a positive. Negative 16 times a negative 1, 16 times 1 is 16. Negative times a negative is positive. Z equals 16. And then we can go up here and check. Is it true? 71 minus z equals 55. Yes, it is. All right, now I want to do this another way for you. We started here and we had 71 minus z equals 55. I could add a z to this side and add a z to this side, cancel those out, and I've got 71 equals 55 plus z. Now you'll notice my z is positive, but I now have a plus 55 in the way of z being by itself. I still need to isolate that z. So I want to get rid of this plus 55. How am I going to do that? You're right. I'm going to subtract 55. If I subtract 55 from the right side of the equation, guess what I have to do to the left? I have to subtract 55. All right. Now, 55 minus 55 is 0, and I have z equals 71 minus 55. We know that is 16. Both work. Pretty amazing, huh? Cool stuff. All right, let's go on to another warm up. You're gonna be amazed at how much this comes back to you and how much you grow from the first time we talked about this at the beginning of the year. We're just kind of adding on to it a little bit. And then next year as an 8th grader, you're going to add on to a little bit. And then 9th and 10th. We're going to come back to those chapters 9 and 10, but I felt like chapter 11, getting a little more comfortable with manipulating equations, would help us for 9 and 10, for chapters 9 and 10, especially since we can't be in person together. So I can't wait to watch your growth. All right, now we're going to go on to, let's do another one kind of like that. Let's call this warm up number 4. And let's say 18 minus p equals 20. Let's say it equals 12. Let's say it equals 12. 18 minus p equals 12. Okay? So I want to isolate the variable. I want to get p by itself. And again, notice p is negative. All right. So I can either move p over here, my negative p, add a p and add a p, or I can just wait until the end and multiply by -1. It's your choice. The first one I'm going to solve the way we did the other time. I'm going to first get rid of the -18. If I subtract -18 from the left, I've got to subtract 18 from the right. Now I'm left with negative p because those cancel out. 18 minus 18 is 0. Negative p equals -6. 12 minus 18 equals -6. Remember, when we subtract negatives, it's like saying 12 plus a -18. All right. What's the difference between 12 and 18? The difference is 6. Then we take the sign of the number that appears larger. We know that -18 is smaller than 12, but it looks bigger because it's the number 18. So that's the sign that we're going to keep. So our answer is -6. Now we're left with negative p equals -6, and we're simply going to multiply both sides by a -1 so that our answer can be a positive p equals -6 times -1 is 6. Notice all of these lines of work, I'm going straight down from the top down. I'm showing all my work. Please, please, please do not be tempted to skip over steps because it's so easy right now. Yes, it's easy right now, and you may be able to skip steps, but soon you'll be in, you'll have a problem in front of you where you are unable to skip steps. And I want you to be so comfortable and grounded in the steps that you can do it without a problem. Know that I'm on your side. Follow my directions. And now let's look at the other way we could solve this problem. 18 minus p equals 12. And then if I were to add p to both sides, I'm going to add p to the left side and add p to the right side. Negative p plus p cancels out, leaves you with 0. And then I'm going to get 18 equals 12 plus p. I'm still back at needing to isolate p. But 12 plus 12 is in the way. I got to get rid of it. What's the opposite or the inverse operation of plus 12? It's going to be subtract. So if we're adding 12, we're going to subtract 12. If we subtract 12 from the right side of the equation, we have to subtract 12 from the left side. 18 minus 12 equals 6. 6 equals p. Same answer. I think you're catching on, right? Let's go on to warm up number 5. Number 5, warm up 5, is y over 8 equals 9. Now, I'm going to rewrite this. Y over 8 equals 9. And I'm also now going to change my 9 into a fraction. The whole number 9, if I simply put it over 1, is a nice way to look at it and say, oh, 9 is a fraction. Does 9 divided by 1 still equal 9? Yes. I can put anything over 1 to make it a fraction, and it's still going to be itself. Now, I want to isolate the variable. Well, my question is, what's in the way of y being by itself? divide by 8 is keeping y company. We want to kick divided by 8 out. How do we do that? What's the inverse of divide by? It's multiply by 8. Multiply by 8 over 1. If I multiply the left side by 8 over 1, guess what I have to do to the right side? Multiply it by 8 over 1. Remember with fractions, when you multiply numerator times numerator and denominator times denominator. So we're going to say 9 times 8 and 1 times 1. In this case here, these cross cancel. 8 divided by 8 is 1. 8 divided by 8 is 1. Straight across, I'm left with y over 1 times 1 is 1. What is y divided by 1? Y divided by 1 is simply y. 9 times 8 is 72. 1 times 1 is 1. Y equals 72 divided by 1, and my answer is 72. Let's try another one. I just want some, let's go with orange, maybe. I want orange. Let's see here. Orange color, let's do warm up 6. X over 5 equals 4. So I'm going to rewrite my problem. X over 5 equals 4. And notice we're dealing with fractions. X divided by 5. So I'm going to put 4 over 1. And now I want to get rid of this divide by 5 that is keeping this X company. I need to isolate X. Okay, so how do I do that? I'm going to multiply by 5 over 1. X is divided by 5. The inverse operation is times by 5. If I multiply the left side, I've got to multiply the right side. So I'm going to come over here to 4 over 1 and multiply it by 5 over 1. 5 and 5 cross cancel. X times 1 is just 1x, which is x, equals, straight across, 4 times 5 is 20. 1 times 1 is 1. X equals 20 divided by 1, which is 20. And that is warm up 6. I hope this is kind of, bringing up some memories of doing this earlier. So for right now, I'd like you to turn to page 470. And let's do some problems together on 11-1. So again, I'm on page 470, and you can pause the video while you get some paper and get ready, and then come back and we'll start. Number 1, 3n plus 8 equals 29. So my first step, I'm going to rewrite my problem. And then I'm going to ask myself, okay, I notice here I've got an 8 in the way. I've got a 3 in the way. Wait a minute. Don't freak out. Just remember, this is adding a step to what we've already done before in the past. First, I want to know, what is my variable? My variable is n. What's in the way of n? A times 3, but let's not worry about the stuff that's connected to n right now, but rather look at this plus 8. Let's get rid of that plus 8. How do we get rid of plus 8? We subtract 8. If we subtract 8 from the left, we have to subtract 8 from the right. Then you're going to bring everything down. 3n, 8 minus 8 is 0. Bring down my equal sign. 29 minus 8 is 21. Now I'm left with 3n equals 21. Now I've still got something clinging on to my n, and I want to get rid of it, and it's a 3. And what operation is being performed on n? Times 3. What's the inverse of times 3? Divide by 3. If I divide the left by 3, I got to divide the right by 3. 3 divided by 3 is 1. 1 times n is n. N equals 21 divided by 3. N equals 7. Now we can go back up here and plug it in. What if we do 3 times 7 plus 8? Does it equal 29? 3 times 7, order of operations, and we're going left to right. 21 plus 8 is 29. Yep, 29 equals 29. Let's do number 2. Number 2, negative 4m minus 7 equals 17. Negative 4m minus 7 equals 17. My first step, I'm going to rewrite the problem. Then I'm going to look and I'm going to say, okay, my variable's m, but it's connected to a 4. So I'm going to go searching for something else. Okay, I see this negative 7. I want to kick it out. Negative 7, inverse operation would be plus 7. If I add 7 to the left, I've got to add 7 to the right. Negative 4m equals 24. Now I look at my m and I still need to isolate it further. What's in the way of my m? A times negative 4, a negative 4. It's being multiplied to m. So what's the inverse of times negative 4? It is divide by negative 4. If I divide the left by negative 4, I got to divide the right by negative 4. Negative 4m divided by negative 4 is m. Negative 4 divided by negative 4 is 1. 1 times m is m. 24 divided by negative 4 is negative 6. So 24 divided by 4 is 6, and then a positive divided by a negative is going to be negative. M equals negative 6. Now, if you want to go back up and see if it works, you can say negative 4 times a negative 6, because I'm plugging negative 6 in for that m, minus 7 equals 17. Notice I'm just taking the m and plugging it in for negative 6. Negative 4 times negative 6 minus 7 equals 17. Let's see if it's right. Negative 4, times negative 6 is going to be 24. Minus 7 equals 17. 24 minus 7, guess what? It's 17. 17 does equal 17. Notice you got to watch the signs. A negative times a negative is a positive. And then minus 7, bring everything down. 17 equals 17, so we know that that is correct. Whoop, whoop. Oh boy, technical difficulties. All right, let's move on. You can start and get ahead of me a little bit and write down number 2. Number 2. Not that. Wrong problem. Number 2, negative 4m. Never mind. Let's do number 3. Number 3. 2 equals, see how I need you guys? You guys keep me on track in class and you help me out. I miss you. All right. We have 2 equals negative 6x plus 4. What's our variable? Our variable is x. We see that we have a negative 6 being multiplied to the x, but we want to look and make sure everything out here is out of the way too. So let's get rid of that plus 4. But first, before we do that, why don't we rewrite the answer? We have a positive 4, so to get rid of the plus 4, I want to subtract 4. If I subtract 4 from the right of the equal sign, I have to subtract 4 from the left of the equal sign. 4 minus 4 leaves me with 0. And then I'm left with, when I bring everything down, negative 6 equals, what's 2 minus 4? What's the difference between 2 and 4? The difference is 2. And the sign of the number that appears to be larger is a negative. Then I see that my negative 6x, I still want to get my x isolated. I got to get rid of that negative 6. So it's being multiplied to x. Negative 6x being multiplied, I want to do the inverse. I'm going to divide by negative 6. If I divide the right by negative 6, I have to divide the left by negative 6. So negative 6 divided by negative 6 is 1. 1 times x is x. Bring everything down and work. Remember, you just keep working back and forth, left to right. Don't skip around, okay? Negative 2 and negative 6 divided. Negative divided by negative is going to give me a positive. And so I'm going to divide by 2, and my answer is going to be 1/3. I can go back up and I can plug in 2 equals negative 6 times my x, which is 1/3, plus 4. 2 equals negative 6 over 1 times 1 over 3 plus 4. And we're going to get this. Negative 6 times 1 is negative 6. 1 times 3 is 3. Negative 6 divided by 3 is negative 2 plus 4. The difference between 4 and 2 is 2. The sign of the number that appears larger is positive. And so I'm going to get 2 equals 2. It checks. And so we were correct. Nice job. Let's go on to number 4. Number 4. 12 plus b over 6. Remember, write neatly. I want to be able to read everything. Equals 16. Here we have a fraction with our b over 6. So right now, b is being divided by 6. I want to get rid of anything out here in the way before that. But before I do that, I'm going to rewrite the problem. I'm going to subtract 12. If I subtract it from the left, I have to subtract it from the right. Then I'm going to have b over 6 equals 16 minus 12 is 4. Now I notice that b is being divided by 6. Our variable is b. We want to get rid of the divide by 6. How do you get rid of divide by 6? You multiply by 6. Multiplication is the inverse operation of division. So I'm going to multiply by 6 over 1. If I multiply the left side, I have to multiply the right side. So I'm going to multiply by 6 over 1. Remember, I can turn that 4 into a fraction by putting it over 1. So now 6 and 6 cross cancel. B times 1 is 1b, which leaves us with b equals, multiply fractions straight across to solve them. 4 times 6 is 24 over 1 times 1 is 1. B equals 24. Number 5. Y over 8 minus 15 equals 2. First thing to ask ourselves, did you rewrite the problem? No, I didn't rewrite the problem. I will do that now. All right, y over 8 minus 15 equals 2. Notice I'm dealing with a fraction again, and every time you see a fraction, you know what operation that indicates. That indicates the operation of division. So y divided by 8 minus 15 equals 2. Right now, I'm not going to worry about the number or the action that's so closely related to the y. I'm going to get rid of the minus 15. Minus 15, the inverse operation is plus 15. If I add 15 to the left, I have to add 15 to the right. These cancel out. Negative 15 plus 15 equals 0. Then I'm left with y over 8 equals 2 plus 15, which is 17. Now I need to isolate that variable further. I want to get y completely alone. Y divided by 8, what's the inverse operation of divide by 8? It is multiply by 8 over 1. If I multiply the left side by 8 over 1, I have to multiply the right side by 8 over 1. It is an equation, and you have to be equal and share on both sides the same in order for it to stay balanced. Okay? 8 and 8 cross cancel. Y over 1, or y times 1 is simply 1y. 1y is y. I can put 17 over 1 to turn it into a fraction. I can look for ways to do any cross-reducing, and there aren't any ways. So I can simply multiply 17 times 8, which is, we've got to do this real quick. $136. Y equals 136. And then straight across, 17 times 8 is 136. 1 times 1 is 1. Y equals 136. All right, we're trucking along. I'll erase and we'll go on to the next one. Number 6. 10 equals negative 8 plus n over 4. 10 equals negative 8 plus n over 4. All right, so our job first is to rewrite the problem. Okay. Then I want to isolate the variable. The first thing we can get out of the way is this negative 8. So in order to use the inverse operation and undo minus 8, we're going to add 8. If we add 8 to the right of the equation, we're going to add 8 to the left side. Negative 8 plus 8 adds up to 0, and we're left with n divided by 4 equals 10 plus 8, which is 18. Now, to further isolate the variable, we have n divided by 4. The inverse operation of division is multiplication. It's being divided by 4, so now we're going to multiply by 4. And we can simply turn 4 into a fraction by putting it over 1. If I multiply the right side by 4 over 1, I have to multiply the left side by 4 over 1. I'm going to be left with n divided by 1, which is n, equals 18 times 4. What's 18 times 4? It's 72. 1 times 1 is 1. 72 divided by 1 is 72. 72 equals n. Kind of fun once you get the hang of it. It's something that'll be kind of nice to do and feels good when you figure it out and it works out. So let's go on to number 7. Number 7. A coffee shop sells a ceramic refill mug for $8.95. Each refill costs $1.50. Last month, Rose spent $26.95 on a mug and refills. How many refills did she buy? So the important part with story problems is to not get impatient and think, oh, here comes a story problem. It's going to take forever. Yeah, they do take a little longer, but they're kind of fun. And once you get the hang of it, you'll really start to enjoy them. Can't wait for that day, huh? So let's reread it one more time, and then let's write down some information that we need from it. A coffee shop sells a ceramic refill mug for $8.95. So initial cost is $8.95 for the mug. Okay, I'm going to write that down. Each refill costs $1.50. So I'm going to write down that information. Refills are $1.50. Okay. Last month, Rose spent $26.95 on her coffee. So $26.95 equaled her mug plus her refills. So the question is, how many refills did she buy? So let's look at this. We know she spent $26.95, and we know the mug costs $8.95. Okay. The question is, we wonder how many refills she bought at $1.50. The number of refills is our variable that we've got to figure out. So we're going to assign refills. Let's call it R for refills. So our new equation looks like this. $26.95 equals $8.95 plus $1.50 R for refills. And now we have our equation and we can figure out how many refills she got. The first thing we've got to recognize where our variable is. Our variable is $1.50. Excuse me, our variable is R, and it's connected to times $1.50. Because if she got 2 refills, she spent $3 on refills. If she got 3 refills, she spent $4.50 on refills. The R is our variable. The answer is going to be dependent on how many refills she had. So we want to get rid of this $8.95. So we're going to subtract $8.95. If we subtract it from the right side of our equation, we have to subtract it from our left side of the equation. $8.95 minus $8.95 is 0. And so we know now if we bring everything down, $1.50 R equals $26.95 minus $8.95. See if you can beat me on your calculators at home while I do this. And the answer is $18 equals $1.50 R. Now we still need to solve for R. We're going to figure out how many refills she got. $1.50 is being multiplied by R. So now you're going to divide by $1.50. If you divide the right by $1.50, you have to divide the left by $1.50. $1.50 divided by $1.50 is 1. 1 times R is R. $18 divided by $1.50 is 12. How many refills did she have that month? 12 refills. All right, I hope this helps, and feel free to let me know if you need any further help, but I wanted to kind of go through this so that you knew how to tackle your assignment. And what I would like you to do for your assignment would include page 470, lesson 11-1, and I would like you to do numbers 9 through 20 all. 9 through 20 all. Have fun, and we'll talk to you soon. Bye-bye.